Hi, I'm Mr. Oh Ming Yeo. Okay, now we are going to look at the difference between heat capacity and specific heat capacity. Okay, now let's look at heat capacity first. Heat capacity is represented by a capital letter C. And okay, for example, let's say that the heat capacity of an object is 300 joules per Kelvin. This actually means that 300 joules of heat energy is required to raise the temperature of the body by 1 degree Celsius or 1 Kelvin. Okay, and now let's move on to the formula for heat capacity. Let's use it on a question here. Okay, 12,000 joules is required to heat up a body of water from 30 degrees Celsius to 70 degrees Celsius. The heat capacity formula is heat capacity is equal to Q over delta theta. This Q is actually the heat energy in joules, and delta theta is the change in temperature in terms of degrees Celsius or Kelvin. So in this case, the heat energy that is required will be 12,000, and the change in temperature will be from 30 degrees Celsius to 70 degrees Celsius will be 40. So the heat capacity for this body of water, it will be 300 joules per Kelvin. Okay, the disadvantage of heat capacity, right, is that it doesn't tell you what is the mass of the substance that is involved. So 300 joules is required to heat up that body of water by 1 Kelvin. So how much is that body of water, we do not know. Okay, that is why we have another term called the specific heat capacity. Okay, now for example, specific heat capacity, which is represented by a small letter C, is equal to 4,200 joules per kg per Kelvin. This means that 4,200 joules of energy is required to heat up 1 kg of the substance by 1 degree Celsius or 1 Kelvin. Okay, same thing, let's look at a question and then we can use the formula for specific heat capacity. 84,000 joules of heat energy is required to heat up 2 kg of water from 10 degrees Celsius to 20 degrees Celsius. Okay, the formula for specific heat capacity, right, is actually equal to heat energy, which is represented by capital letter Q, divided by the mass and delta theta. Okay, let's recap again. Q represents the heat energy, which is expressed in terms of joules. M is the mass, which is represented in terms of kg. And delta theta is a change in temperature, which is expressed in degrees Celsius or Kelvin. Okay, so the heat energy in this case will be 84,000 joules. The mass is 2 kg, and the change in temperature from 10 degrees Celsius to 20 degrees Celsius, it will be a difference of 10. So if we work this out, we find that the specific heat capacity of water is 4200 joules per kg per Kelvin. So this means that 4,200 joules of energy is required to heat up 1 kg of water by 1 Kelvin.